My name is Dana Yaptangco. I am a Fulbright student doing research on exoplanets in Chile. So let's start by answering the question of what is an exoplanet? Well, an exoplanet is a planet that is orbiting a star other than our sun. So just how far away are these things exactly? This is a video zooming out from Earth. As we zoom out past the solar system, we'll get a glimpse of the farthest human-made object from Earth, Voyager 1, at about 20 billion kilometers away. As we zoom out even farther, we'll finally see the most nearby star system to Earth, which is Alpha Centauri, which happens to host the most nearby exoplanet at about 4 light years away. So all of this is to say that exoplanets are so far away that we can't exactly just go visit them or even take pretty pictures of them like we can of Mercury or Jupiter. The best we can do is take pictures of these little blobs of light. So these 4 little blobs of light are exoplanets orbiting around the central star. This is done using an advanced technique called direct imaging, where we block out most of the light from the central star. It's a little bit like trying to photograph fireflies around a lighthouse. So if this is the best we can do in terms of photos of exoplanets, you might be thinking, that's it? But I'm here to tell you that despite the challenges and the distance, there is actually a lot more that we can still learn about exoplanets. But before I get ahead of myself, let's answer the question of why we care about what exoplanets have to tell us. Well, for one thing, we know very little about the origins of the Earth. We can't exactly just turn back the clock and watch Earth be formed from the beginning. But what we can do is look at other star systems and their protoplanetary disks. These are protoplanetary disks. They are basically the birthplaces and nurseries of young exoplanets. At the center of each of these disks is a young star, and it's possible that some of these gaps in between rings are caused by young exoplanets collecting material, much like this young exoplanet located within its protoplanetary disk. By watching these young exoplanets form and evolve, we can get a glimpse into our own past. Besides answering the question of where did we come from, we might also be interested in answering the question of are we alone in the universe? Up until this point, there have been thousands of exoplanets discovered. And with this incredible diversity of planets, we have found some that are beyond our wildest imaginations, including some which may be hospitable to life. For some examples, we have planet 55 Cancri E, which is a planet that's so close to its star that it's probably covered in lava. There's also planet Kepler 22b, a possible water world, which is located at just the right distance from its star where liquid water can form, possibly making it hospitable to life. With so many exoplanets found up until this point, we can do more than just study individual exoplanet systems. We can actually get an idea of the general behavior and trends of exoplanet populations. And this is a study called exoplanet demographics, which is what I do here in Chile. Using exoplanet demographics, we can get an idea of which types of planets can form around which types of stars, and how their environments affect the way they evolve over time. In order to do this kind of research, we need a lot of data. And one way that we collect a lot of this data is using the exoplanet detection method called the transit method. So basically, the way the transit method works is that if there is a planet crossing in front of a star from our perspective, it will create a dimming signal. And there's actually a lot that we can tell from this dimming signal. For example, how fast the planet is moving, where it's located, and how large it is in comparison to the star. We're able to do this kind of research from a lot of different telescopes, including the TRAPPIST telescope, which is located here in Chile, which famously found a system with 7 Earth-like exoplanets. There's also the TESS Space Telescope, which is located in outer space. And there's the Las Campanas Observatory, also located in Chile. I decided to come to Chile to do this research to work with some of the top exoplanet researchers in the world. On top of the incredible telescope resources here and the beautiful clear skies, the thing that really makes Chile an attractive place to do research is the flourishing scientific community. It's an incredible opportunity for me to come here and connect with researchers in order to start long-term international collaborations that enrich the science we're able to do. If you remember the transit method from a little while ago, we can do more than just exoplanet demographics with transits. We're also able to get a glimpse into exactly which compounds and molecules exist in exoplanet atmospheres. Using the most cutting-edge telescopes of our time, like the James Webb Space Telescope and located in Chile, the VLT, and the ELT, we are starting to be able to get a detailed look into exactly which compounds and molecules exist in exoplanet atmospheres. We're currently on the lookout for a biosignature, which would be a signature of extraterrestrial life. For example, oxygen located in an exoplanet atmosphere. You may have recently heard the announcement of a biosignature detected around planet K218b. I'll let you in on a little secret that it's not quite yet a robust detection of a biosignature, but I will say that we are the closest we have ever been to finding a definitive signature. And it could very well be located around this planet. So you might also be wondering, even if we do manage to find a biosignature, then what are we going to do? Well, earlier I mentioned that exoplanets are too far away to just go visit, but actually there are already some plans underway to turn humankind into an interstellar species. One of these is Project Starshot, which plans to send a probe at about 20% the speed of light in order to reach the nearest exoplanet system in 22 years rather than thousands. In conclusion, astronomers are using every tool at our disposal to learn everything we can about exoplanets, learning about where we come from, which planets may be hospitable to life, and if we're alone in the universe. In order to do this incredible research, it takes international collaboration and respect in order to uncover the secrets of these distant but not out of reach worlds. Thank you.